So building a bridge foundation in the deep ocean is like conquering an alien world. Miles of crushing water, unpredictable currents. It all starts with site selection, scanning the ocean floor for the perfect spot using sonar and seismic surveys to avoid faults and soft sediment. Teams deploy ROVs, remotely operated vehicles like underwater drones, mapping every inch with lasers and cameras for precise blueprints. Environmental assessments ensure we protect marine life, dodging restore mariners and quail everything. In the design phase, civil engineers model the foundation using software to simulate waves, earthquakes, and tidal forces. For deep ocean, we often use caissons, giant watertight boxes or steel tubes hammered into support. Construction begins with floating barges and crane ships arriving on site, loaded with thousands of tons of steel and concrete. We position the fleet using GPS and dynamic positioning systems to hold steady against currents that could drift us miles off course. Seabed preparation, dredgers scoop away loose sediment, creating a flat, stable base, sometimes blasting rock if it's too hard. Once on the seabed, we pump out water and air to create a dry workspace inside, allowing workers to excavate down to solid bedrock. For caisson foundations, we lower the massive structure up to slowly into the water, guiding it with tugboats and divers. If using piles, hydraulic hammers on floating platforms drive steel pipes hundreds of feet deep, vibrating the ocean with each thunderous blow. Divers and saturation teams work in pressurized bells, facing risks like decompression sickness while welding and inspecting underwater. With the caisson shell in place, we pour tremi concrete, a special mix that sets underwater, through tubes to fill voids without washing away. We build up in stages, adding concrete layers inside the caisson, sinking it deeper as we go until it hits unbreakable rock. Steel rebar grids are woven in, creating a reinforced concrete core that's tougher than the ocean's mightiest wave. Sensors monitor everything: vibrations, pressure, alignment, feeding data to engineers on shore for real-time adjustments. Challenges abound. Hurricanes halt work, forcing evacuations, while corrosion from salt water demands special protective coatings. We mitigate impacts with bubble curtains to shield marine animals from noise, proving engineering can harmonize with nature. Once the foundation is set, we add a pier cap, a massive concrete slab to connect to the bridge towers above. Load tests simulate earthquakes and ship collisions, ensuring the foundation can withstand forces equivalent to 1,000 elephants. Multiple foundations align perfectly across miles of ocean, a symphony of human ingenuity linking distant shores. This epic build can cost billions, employing thousands, but it boosts economies by connecting communities forever. Future tech like 3D printed foundations and AI monitoring will make deep ocean builds faster, safer, and greener. The completed foundation rises from the abyss, a silent guardian ready for the bridge deck to span above. From viral bridge rubber to this oceanic marvel, civil engineering turns nature's obstacles into pathways of progress. Its foundations defying 200-meter depths and massive quakes. Whether you're a budding engineer or just love epic feats, remember, the ocean's depths are no match for human resolve. Thanks for watching. Hit like if this blew your mind and follow for more engineering adventures.